updated the box simulation, I had it hit the sphere instead of the ground because I want to adjust the spark system to be able to handle a little bit more complex animation. I will put how I changed the system at the end of this video. So in my Spark setup, I'm first gonna version up. So file save as, version 4. And then I'm gonna bring in the new camera I created. So file, import, Alembics scene. And then in here, I called it camera version 2. Import, and we have the new camera just on top of my old camera. And it's here, nothing to see yet. Then I'm gonna go back into the system. I'm gonna replace the box. So in here, I am going to choose Sparksbox version 2 and accept. And let's play. I'm gonna reduce the timeline to maybe 40. Then I added this transform earlier, so I just wanna remove this one so this transform doesn't do anything anymore. And next, let's bring in the collider. So I'm gonna put down another Alembic node. And in here, I'm gonna find my new collider and take a look, and then I'm gonna unpack it. And I wanna toggle convert polygon soups primitive to polygons. Then I'm gonna create a null for it. And let's just call it collider. And then down here where I have the Spark setup, I have the new box already imported, but I want to replace this grid with the sphere. So I'm just going to do an object merge. And then I'm going to pick up this collider, put it in the object. We got the sphere, replace the grid. And then this checks the distance and then scatters when the box is close to the sphere. So let's see. So it's close to the sphere for one frame. I think I'm just gonna move the box around to get a little bit more contact. So first of all, I'm gonna merge these two together just to take a look at it. And then in this transform node, so I'm just gonna move it in set a little bit like this. And I think now, hopefully, yeah, we got a few more frames of contact. I'm gonna move it a little bit more. Get a good contact going. Something like this. The points are scattered. And then they are run through the simulation down here. Something like this. Inside the simulation, I'm going to replace the ground plane with the sphere. So I'm going to put down a static object. And I want to pick up the ground from up here. So I'm going to guide this node to it. So out of this node, up one level, and then it's called collider. Or you can use this menu, and then instead of geo, you have collider. The sphere is not moving, so I don't have to check this one. And then I'm just gonna connect it instead of the ground. And just in case, I want to look at the actual simulation geometry, which is this one. Now it's set to use solver default for the collision detection, but I'm pretty sure the pop solver uses a volume collision. So that is this tab here. Yeah, the sphere looks fine. Let's play the simulation again. And you can see the particles are colliding with the sphere. Let's hide both now. Okay. Delete this one and back upstairs. Now let's figure out the deformation. So here we have the grid again, so I'm gonna replace this with the sphere. So I'm gonna put down an object merge. And then to pick up the sphere, I'm just gonna say dot dot to go out of this node, and then slash, and I know the null for the sphere is called collider. So I'm gonna pick him up here, and then I'm just gonna replace the grid. I'm just gonna subdivide this to start with. And let's see, something like this. Then I want to update this subdiv group. So I'm just going to say revert to defaults and revert to defaults. And I actually want to take a look at the box in the template now. So if we find a frame where it's hitting, and now to be able to adjust this transform inside the scene view, I'm just going to place the mouse above the scene view and press enter. And then I can move this guy to include everywhere where the box hits the sphere. And now this subdivide node will subdivide based on this group, subd. I don't know, maybe we just need like a little bit, something like this. I guess this is enough. And then we bring in the box. And the box animation has been already updated, so that's good. I remesh it, and then give it an attribute called subd and set it equal to 1. On the left side, I give the sphere the same attribute, but set it equal to 0. And then I use an attribute transfer to transfer this attribute, subd, from the box to the sphere. And to take a look at it, we can put down a color node. And I'm going to say ramp from attribute. And the attribute is subd. And if I go back, you can see where the box hits the sphere. And we enter the solver. Let's reset the simulation. And now everywhere where the box has been close to will keep the subd attribute as 1. So it's basically just checking the current frame and the previous frame and taking the maximum subd value. Then we time shift it to the last frame. So this is frame 40, and then we promote subd from points. So it's gone from here, and now it's a primitive attribute. And you can take a look at it again just by changing this color node from point to primitive. And then we subdivide everywhere where subd is 1. So we're going to be able to have some detail close to where the box hits. Then here we have the box again. And we remesh it, give it some mounting. And then we ray the sphere onto the box, but it doesn't really work because we are raying it downwards in the direction of y is -1. So what I would like to do instead is I want to use the normals of the sphere and ray the sphere onto the box in the opposite direction of these normals. So in here we can select direction source normal, and then we can set the direction type to reverse. So we almost got it working, but we got some weird stretched primitives, and that's because some points from the other side of the sphere are being rayed also. So I only want to ray points that are in this area. And remember from before, we have this attribute subd, so we can just use that again. So in here, only ray if the attribute subd is equal to 1. And now it will only array the points that have the sub-d attribute of 1. So we got the deformation, but I need to figure out how to preserve it throughout the animation. One thing we might consider is go back to this remix node and let's take this one a little lower. Let's see how this looks. Something like this. This solve won't work anymore because inside of here I'm comparing py to the previous py and taking the minimum value. So we can just remove this one. What I want to do is to say, unless you are currently being deformed, take the position from the previous frame. First, I need some way to know if the points are being deformed or not. So if these points are in a different position from what they used to be here. And to do that, I'm going to use an attribute wrangle. And I'm basically going to compare this ray to whatever was up here. And then I want to write it out to an attribute that has the value of 1 when it's not in the same position as before, and value of 0 when it is in the same position as before. So it's going to be an integer attribute, so I, and then I'm just going to call it hit. And I'm going to set it equal to the length of the current position, and it's a vector. And subtract from that the position from the second input. So I'm going to use a point expression. It's the second input, so it's input number 1. The attribute is called p, and then I just want to compare the same point number, so at pgnum. So the length of this, and if the distance between p coming from the first input and the p coming from the second input is anything other than 0, this will return 1, otherwise it will return 0. And you can see we have this attribute here. It has the value of 0 to 1, but let's take a look at it in color. Ramp from attribute, hit, and you can see only the points that have moved have the hit attribute of 1. You can connect this into the solver. I guess we can keep this color. I'm just going to make this a little lighter gray so it's easier to see. Connect it in here. And in here I'm going to put down an attribute swap. And I'm going to connect the current frame and then the previous frame to the second input. Go inside of here. And then I want to bring in the previous frame that comes in through the second input. So I'm just going to put down an import point attribute node. And I want to pick up P, but I want P from the second input. So if you connect this to P, you can see you have the P of the second input. Then I want the hit attribute, so I'm just going to put down a bind. It's coming through the first input, so we can just use a simple bind. In here, I'm going to say hit, and I know it's an integer attribute. Okay. I'm just going to go upstairs, get rid of this color, and we can just see the color in here instead. Like this, just to see it's working. So now what I want to do is I want to switch between the current P and the previous P based on the hit attribute. So I'm going to put down a switch. Hit is going to be the attribute I'm going to use to switch. And when hit is 1, it means that these points are currently being deformed. I want to use the current frame, but when the hit is 0, I want to use the previous frame. So the previous frame goes first, and then the current frame goes second. And then we can connect that to the output P. And now if you play the simulation, you can see, and we untoggle the color, that we're actually preserving some deformation. It's a little chaotic, but it's good enough. Then after the simulation, we can subdivide where sub t is 1. Maybe it's a little bit too much subdivision, so I'm just gonna remove this for now. We can smooth wherever sub t is 1. Let's look at this from the camera. We got a little bit of stepping. I might actually go up here and remove some of these subdivisions. Let's see how this looks. Takes a little bit to reset, and then if we smooth this, something like this. We can revisit the substeps, but I don't really want to. Up here, let's take it down to 1. And now we reset the simulation. We have something like this, and if we subdivide, or if we smooth first. I don't know. You just kinda have to figure out what look you like. Okay, and then I can write this out to disk. And since I updated the hip name to Sparks 4, this won't override my old cache. I'm just going to save this to disk. And then bring it back in. So it's version 4, accept, and we got it here. I'm gonna save the scene, go into Solaris. So first of all, I want to bring in the new camera. So in here, we have another camera. I'm gonna bring this one. So now we got 2 cameras. Going to change to the Karma CPU, hide the grid, hide the light, make the background dark again. Looks something like this. Then down here in Sparks, I'm going to make sure to change the camera. I'm going to change it to camera 2. And then again, I can just write it out to disk without worrying about overwriting because I updated the name of the hip file. And I render to disk. And the render just finished, so I'm gonna check it out in mplay. Sparks 4, this one, load, and let's play. And we got some deformation and some sparks. So I'm gonna change the animation for the box. I think I'm just gonna throw it up in the air and have it hit something maybe. So I'm gonna visit the initial velocities in here. Instead of throwing it downwards, I'm gonna throw it upwards. Let's see how this looks. I'm also gonna reduce the X velocity. Maybe I throw it a bit higher. 4. Oof, this is high. Take this one down. I'm just gonna remove the drag for a little bit. Okay. And then I'm just gonna put a sphere in its way that's gonna hit. So, gonna make it pretty big. Find a good frame for it to hit it. Maybe here. I want to kind of make it hit it on the side, so let's do this. Something like this. And then I'm going to use this as a collider. That will be the fourth input of the RPD's bullet solver. Connect it, and in here, in collision, you can see the properties for the collision geometry. It's just static, and convex hull is fine. So let's play the simulation again. You can see it actually hits the sphere. Let's go a little closer. We can move it around a little bit more. Maybe change its shape a little bit. We can take the friction down. Let's try with 0 and let's take the bounce down too. Let's see if we get it to slide. Move it a little bit to the side again. Actually, maybe we can rotate it. Something like this. Let's look at it together. I'm going to increase the initial velocity a little bit. Let's multiply it by 4 instead of 3. Let's try that. Maybe you can adjust the shape of the sphere again. Maybe make it a little higher, like this. And then there is a big question, where should we put the camera? Yeah. New camera. Okay, camera 1 and camera 2. I'm gonna go in here. I am going to write this out of disk. And first of all, before I do everything, I should have versioned up. So I'm gonna do File, Save As, version 2 for my new animation. And in here I'm gonna do the same, version 2 for the box, and write it out of disk. And then I also wanna write out the collider. And that can be just any frame because it's static. And I'm gonna call it Sparks collider version 1. Then I also want to export the camera. So I'm gonna say File, Export, Alembic, just get the camera. And I'm going to call it Camera version 2. Accept and export.